welcome back to all of you on your channel once again. So today we are going to start the JEE Advanced 2026 journey, and I'll come up with a series of problems which will not only enable you to solve these HOTS, that is higher order thinking skills, and it will also develop you, it will also help you to generate the thinking skill, to coagulate the ideas, to sink in few concepts and how to tackle these kind of questions. So the purpose of doing this series will be that you on yourself will be able to develop such questions. You will be able to modify the questions. You can modulate, demodulate or remodulate these questions. So the purpose is that the purpose is not mugging up. The purpose is not just checking these questions. The purpose is what can be built around the question, right? So without wasting much time, let's start. So in this particular question, this is based on the rolling of a coin on a tabletop. So if you have a horizontal table where a coin is rolling, if there is sufficient friction, the coin will keep on rolling in the circle, as you can see over the circle of capital R. There are a few key words. This is the most important key line, that the coin will be leaning inward. The axis will be tilted. It will not be very upright. If it is in equilibrium, then it will keep on rotating. It has a velocity v. Assume that there is no slipping. That means they're assuming the case of pure rolling. It has to be the case. Find the angle alpha that the axis makes with the horizontal. So first, let us understand the dynamics of the coin over here. So it has two motion. First of all, the center of mass of the coin, or the center of the coin, since it is geometrically symmetric, is moving or revolving around this axis with angular velocity capital omega. So immediately I will write V center of mass will come how much? It will become capital omega into capital R. At the same time, the coin is also spinning about its own axis. So it has a velocity of spin angular velocity omega into b. Now, since they have said that there is no slipping, it is in pure rolling, so this velocity will be in the opposite direction. So this will be equal to omega into small b. So this is equal to omega into small b. From here I am writing my first important equation, capital omega is equal to small omega into b by capital R. I hope this point is clear to everyone. So let us say this is my equation number 1. The next equation is I am going to write the force equation. So if I concentrate on the force equation, so there is one force, normal direction, vertical direction. Which force it will balance? It will balance mg. So this is my equation number 2. This friction is acting towards this axis of rotation. So this friction has to supply the centripetal force that will be equal to mv square by capital R. This is my equation number 3. Next equation is what? Next equation is the torque equation. So if you look at the torque equation, I am going to calculate torque about this center. So this is a cross section, frontal cross section. This diagram is all about the frontal cross section. So in torque equation, if I write friction is providing the torque. So if you check out the friction, this is the perpendicular distance which is going to come b cos alpha, because it's a very simple observation. If this is b, this distance is also going to be, then this particular length, this length is going to be how much? B cos alpha. So torque due to friction, F into B cos alpha, minus torque due to normal reaction, N into, what about this distance then? This is B cos alpha. This distance is going to be B sin alpha. So torque due to normal reaction is going to become B sin alpha. That is equal to tau about the center of mass. Aggregating, F is already equal to mv square by capital R. That into B cos alpha minus mg into B, that into sin alpha, is equal to torque about the center of mass. Here I am going to write a very, very important equation. Regarding this, I am going to shortly come up with the 2 videos, but as of now I am leaving this for the brainstorming. You have to do and think on your own. That is tau center of mass for this kind of skew movement. I am going to write capital omega L into cos alpha. Now L is equal to how much? L is equal to nothing but I naught into small omega into cos alpha. We already have the value of capital omega from here. How much you are going to write? Omega B by capital R. How much is I naught? I naught is equal to simply half mv square omega into cos alpha. Correct? By doing proper substitution, leaving the calculation part up to you, we will get the equation as tan alpha is equal to half of v square by rg. Isn't it interesting? Because in case of circular motion, we have seen that tan theta there often comes to be v square by rg, but here it is coming how much? Half of v square by rg. I hope you have enjoyed the question. I hope you have learned to apply new concept, and You have also seen a fairly new type of equation which is applied over here, and this I am leaving up to you so that you will genuinely try this one. If you do like the content, then please like, share and subscribe. Thank you so much. See you in the next question. Bye bye.